Okay, so now we get into the fun part of actually solving right triangles. So again, we can use any of these methods to help us do that. So in this case, they're giving us an angle, they're giving us one of the sides, we're missing a couple sides, we're missing an angle, and it doesn't matter what order you want to do this. So whatever's easiest. So in my opinion, easiest thing, if they give you one angle, let's find the missing one. So in this case, angle N is 51.2, so angle M should be 90 minus that. So which will give you 38.8 degrees. So that's one piece. So next we need to find a couple of the sides. Again, doesn't matter what order you want to do it. You just have to make sure you use the appropriate trig function. So since we have this side, which is next to the angle 51.2, we could use anything with adjacent in it. So if we used tangent would allow us to find side N, so opposite and adjacent. So if we set it up as tangent 51.2 equals opposite, which is N, over our adjacent, which is 124. Now we can just cross multiply. So N should be equal to 124 times tangent of 51.2 degrees. So 124 times 51.2 tangent equals 154.2. And looks like it's in meters. And so then the last side B, you can use one of two options. You can use the Pythagorean theorem, since you got 2 out of the 3 sides, or we could use another trig ratio. So P is the hypotenuse, and so we have the adjacent. Adjacent and hypotenuse is cosine. So cosine of 51.2 should be equal to 124 over P. So same thing, cross multiply, divide. So we want to divide that one. So let's clear that. 124 divided by 51.2 cosine equals 197.9. Now again, there's going to be some round off errors with these problems depending on which method you use and which angles and stuff. So I mean, if you wanted to use 38.8 and use some trig functions, obviously that'll work as well. You should get pretty close to the same results. I always use as a rule of thumb to fall back on definitive things that are given to you. So that's why I like to use the 51.2, just in case you make a silly mistake finding the missing angle. That way you don't have to worry about messing up your other pieces. So again, try to rely on the given information as much as possible. So let's do it one more time. So now they're giving you another problem in a slightly different way. They want you to draw it. So you got triangle ABC with A equal to that and B equal to that. So if we draw our right triangle, now depending on how you label your angles, that's going to dictate where your sides go. So remember, opposite is the rule of thumb. So A is 76.4, so that's going to have to be down here. And then B is 39.3. So that'll have to be over there. So now, where do you want to start? Well, let's find the third side. We got 2 out of the 3. Let's use the Pythagorean theorem. So that's side C. Now, the one thing to keep in mind, obviously you're not drawing this to scale, so be careful because it, the lack of that might cause it to look funny. So if we take 39.3 and square it, and then we want to add 76.4 squared equals so 7381.45. So now let's square root it. So it looks like we get 85.9. And it's going to be in yards. Okay. So that leaves just the two angles. So we're going to have to use a trig ratio again. Now, same thing as before. If we made a mistake finding the third side, what trig function should we use? They're giving us the opposite and the adjacent for either one of the two angles, A or B. So if we're finding angle A, we have the opposite and the adjacent, so we're going to want to use tangent. So tangent of A should be the 76.4 over 39.3. So if we divide that first, that gives us that, and then we're going to want a second tangent it. So 62.8 looks real good. And then to find angle B, we can quickly subtract from 90. So it looks like 27.2. So that kind of gives you a sense of how you can just solve a right triangle. You got a couple of different styles that they could present you with, but this should cover both of those styles. So the next bunch of examples is just going to be more applications. So we'll see them in the next video.